Welcome back to the deep dive. Today we are standing at the intersection of two cultures that honestly, they feel like they have no business being in the same room together.
Yeah, no.
It's a collision of philosophies, and it is causing a massive headache for some of the smartest engineers on the planet.
It is a bit like trying to mix oil and water, or um, maybe more accurately, trying to mix an improvisational jazz band with a military marching band.
That is a fantastic image.
Yeah.
Yeah. On one side, you have the world of modern software development, the whole Silicon Valley ethos,
Right.
the vibe agile, sprints,
Right.
scrums. The mantra is move fast and break things. It's all about iteration, speed, and, well, fixing the plane while you're flying it.
Yeah,
Metaphorically, of course.
right. In that world, if you ship a bug on a Tuesday, you just push a patch on Wednesday. No harm, no foul. Speed is really the currency.
Exactly. But then you have the world of aerospace, the people building the actual metal tubes we all sit in at 35,000 feet.
A very different world.
And let me tell you, if their motto was move fast and break things, I would never set foot in an airport again.
No, absolutely not. In aviation, the currency is not speed. It is certainty. It's rigorous, almost paranoid.
Yeah.
Verification. If you break things in aerospace, you don't send a patch.
No.
You send a search and rescue team.
That is a terrifying but very accurate distinction. So today we are looking at what happens when these two worlds collide. We are analyzing a really dense, fascinating piece of technical research on a new tool called CertiA360.
And it's a proposed solution to a problem that has been plaguing the industry for the better part of 2 decades, really.
And the problem is what exactly? How do you bring the flexibility and speed of Agile into the rigid, regulated, safety-critical world of aviation without violating the law? Because as we're going to see, this isn't just about best practices. This is about federal law.
Precisely. We are talking about the difference between a slightly buggy app on your phone and a flight control system that holds, 300 lives in its hands.
The stakes could not be higher.
Not at all.
So here's our mission for this deep dive. We are going to unpack the research on this CertiA360 tool. We're going to look at the old guard way of doing things, why it's so safe but also so painfully slow.
And then we're going to pop the hood on this new tool.
Right. It's got a 4-layer architecture that claims to automate the boring stuff, the documentation, the traceability, so engineers can actually get back to coding.
And we really need to scrutinize that claim. Because the promise here is huge. It's that you can automate the bureaucracy, that you can have a machine handle the paperwork required by the FAA.
Which sounds like a dream, but also, I have a lot of questions about trust.
As you should.
Can we trust a database to tell us our plane is safe? We'll get into the killer features like automated traceability and impact analysis, and we'll end with a look at the limitations. Because there is a catch, something called DO-330.
There's always a catch in aerospace.
There always is. So let's start with the landscape. Why is this even a problem? I mean, software is software, right? Why can't Boeing or Airbus just hire a bunch of app developers, give them beanbag chairs, and, tell them to use Scrum?
Well, you can try, but you'd be representing a fundamental misunderstanding of the entire environment. To understand why Agile struggles so much here, you have to understand the old guard method.
Okay.
For decades, aerospace has run on what's known as the waterfall model.
Waterfall. I always picture the Gantt charts. Step 1, then step 2, then step 3. Gravity only goes one way.
Exactly. It's strictly linear. It's also called the V model in a lot of systems engineering circles. You spend a massive amount of time up front. I'm talking sometimes a year or more just writing requirements.
A year?
A year or more. Just text documents describing what the system should do.
So you haven't written a single line of code yet?
Not a single bracket. Not
What?
one. You define all the requirements, then you move to system design.
Yeah.
Then high-level software architecture. Then you get into the low-level design.
Right.
And only then, way, way down the line, do you actually write the code. And only after all the code is finished do you even begin testing.
It sounds incredibly disciplined.
It is. It's safe. It ensures that you have, in theory, thought through every single contingency before you build anything.
But the timeline.
But consider the timeline. In a major avionics project, the time between writing that initial requirement and actually testing the code that fulfills it could be 3, maybe 4 years.
3 years. In the tech world, 3 years is a geologic epoch. I mean, if I built an app using Waterfall, by the time I released it, the phone's operating system would have updated 5 times, and my app wouldn't even work anymore.
And that is exactly the economic pain point that the aerospace industry is feeling. Modern avionics. I mean, think about the systems in an F-35
Mhm.
or these new electric air taxis that are coming up. They are incredibly complex systems.
Unbelievably so.
So if you wait 3 years to test, and then you realize you misunderstood a requirement way back in year one,
You're in deep, deep trouble.
you are rewriting the entire system. The cost of fixing a bug, it rises exponentially the later you find it. If you find it in the requirements phase, it costs, let's say, $1.
Oh.
If you find it during testing, it costs $100. If you find it after deployment, well, it costs millions and potentially lives.
So naturally, engineers look at the software world and say, we want that. We want to be agile. We want to iterate. We want to find bugs in week 2, not in year 3.
Exactly. They want that fast feedback loop.
Yeah.
But that is where they hit what the researchers call the compliance wall.
Let's talk about this wall because it has a name, a very scary alphanumeric name.
It does. It's DO-178C.
Software considerations in airborne systems and equipment certification. It doesn't exactly roll off the tongue.
No, it does not. But it is the Bible of aviation software. And unlike, say, the Agile Manifesto, which literally says we should value working software over comprehensive documentation,
Yeah.
DO-178C basically says, I don't care if the software works, show me the paperwork that proves it works.
It seems diametrically opposed. Agile says less docs, and DO-178C says give me all the docs.
It goes deeper than just the volume of documentation. It's about the structure. The core requirement, the one that really kills pure Agile teams, is something called bidirectional traceability.
Okay, let's drill into this. The research highlights this as the #1 pain point.
Yeah.
What does it actually mean to have bidirectional traceability?
Imagine a chain, a long, unbroken chain. At the very top, you have a high-level system requirement, let's say. When the pilot pulls the lever, the landing gear must deploy.
Simple enough. Life or death, but simple.
Right, so that links down to a high-level software requirement, which then links to a low-level design document explaining how the gear deploys mathematically, the logic.
Okay.
That then links down to a specific file of source code, say, landinggear.cpp. And that code, that specific file, links to a specific test case that verifies that it works as intended.
So it's a chain from the idea to the code to the test.
That's the forward trace. And that ensures every requirement you wrote down is actually built. But DO-178C demands the backward trace too.
Okay.
So if I, as a regulator, pick a random line of code in the flight computer, literally line 405, you must be able to tell me exactly which requirement justified writing that line.
And if you can, if there's no link back.
Then it's what's called dead code.
Dead code. It sounds harmless, like just some extra code that doesn't do anything.
It is not harmless. In aviation, extra means unknown. If you have code that doesn't link back to a requirement, it means nobody asked for it to be there.
Right.
It might be a developer's experiment they forgot to delete. It might be a malicious backdoor. It might be a function that interferes with memory allocation in some subtle way you'd never find.
So the regulator looks at that and just says unsafe.
They say, show me the requirement or delete the code. You absolutely cannot have code that doesn't have a reason to be there.
Now, in a waterfall world, you do all this mapping at the end, right? It's a massive paperwork exercise, but you do it once.
Yes. But in Agile, you're changing the code every 2 weeks. You're refactoring, you're deleting modules, you're adding new features.
So just imagine trying to keep a spreadsheet of 50,000 links updated when the developers are rewriting the code every single sprint.
It is impossible. It's literally impossible to do manually without errors. You would spend more time updating the spreadsheet than writing software.
Of course.
And humans make mistakes. You forget to update a row. You link to the wrong version of a requirement.
And that's where the risk lies. Because if the documentation doesn't match the code, you aren't compliant.
And you aren't safe. And we need to talk about DALs here, development assurance levels, because the burden isn't the same for every piece of software on the plane.
Right. The paper mentions DLA through E. Break that down for us.
It's a risk scale. DALE is no safety effect. This is your in-flight entertainment system. If the movie freezes, you are annoyed, but the plane continues to fly.
I might be very annoyed if it's the good part of the movie, but I accept that I won't die.
Exactly. But then you jump all the way to DALA. The designation for that is catastrophic.
Catastrophic.
Loss of aircraft and loss of life. This is the flight control system, the engine controls. The scrutiny for DALA software is intense. Every single line of code must be traced. Every decision justified.
So the paperwork for the coffee maker, which might be DALD, is fundamentally different from the landing gear.
Oh, drastically. But modern planes are so integrated, systems talk to each other. So the complexity just explodes.
And it's not just DO178C anymore, is it? We have supplements now.
Oh, great. More rules.
Exactly. Technology evolved, so the rules had to evolve with it. You have DO331 for model-based development.
Right.
This is where engineers use visual block diagrams like in Simulink instead of writing C++ code to design the systems.
So now how do you trace a text requirement to a picture,
Oh.
to a block in a diagram?
Exactly. That's a huge headache. Then you have DO332 for object-oriented technologies.
Things like inheritance, polymorphism, all the stuff that makes code efficient and reusable.
But makes tracing a nightmare because the code can change its behavior dynamically. It's not static,
Right. And then there's DO333 for formal methods.
which is using heavy, heavy math to formally prove that the software is correct.
So the regulatory landscape is getting wider and more complex. At the same time, the engineers are trying to move faster.
It just sounds like a pressure cooker.
Yeah.
You have engineers who want to use tools they love, like Jira for project management, Git for their code, and maybe something like IBM Doors for their requirements. But these tools all exist in their own silos.
They don't talk to each other, not natively. You have your requirements over here in Doors. You have your user stories and tasks over here in Jira. You have your code commits over here in Git. But the links between them, the traceability, that's often managed manually or via these clunky, error-prone spreadsheet exports.
So you literally have a poor engineer with 3 monitors copying and pasting ID numbers from one screen to another.
Yes, that is a very real scenario. It is labor-intensive, it's incredibly prone to error, and frankly, it burns out your best talent. Nobody goes into aerospace engineering to manage spreadsheets.
No, I can't imagine they do. So this brings us to our protagonist for today, CertiA360. The research paper positions this tool not as a replacement for Jira or Git, but as a third-party integrator.
Which is a very, very smart strategic move.
Yeah.
Engineers are religious about their tools.
They are.
If you walk into a development team and say, hey, throw away Git, you have to use this proprietary tool instead, they will revolt.
They really will. You do not touch a developer's version control system. It's sacred.
So CertiA360 says, keep your tools. It acts as a bridge. It connects what the paper calls the holy trinity of development tools.
And the holy trinity being requirements, project management, and code.
Correct. So for requirements management, it hooks into systems like IBM Doors or maybe Enterprise Architect. For project management, it connects to Atlassian's Jira. And for version control, it connects to Git or SVN.
So it sits in the middle.
It sits in the middle and it listens. It parses data from all these separate systems and it maps them into one single centralized database.
This creates what the paper calls a single source of truth.
That is the holy grail in systems engineering. Instead of having to check 3 different screens or ask 3 different people to see if a code change matches a requirement, it is all there in one view.
And a key benefit here is what they call regulatory adaptability. What does that mean in plain English?
It means the tool isn't hard-coded for just one specific set of rules. It has a configurable rules engine.
Okay.
So if you were working on a project that needs to satisfy the FAA, you configure it for DO178C. But if you're building, say, a medical device, you can configure it for the FDA standards.
Interesting.
It respects the fact that different projects have different compliance needs, but the underlying need for traceability is constant.
Okay, I want to get into the nuts and bolts of how this actually works. Because it sounds a bit like magic. Oh, it just connects everything. But the paper goes into quite a bit of detail on the architecture. They describe a 4-layer architecture.
Yes, and visualizing this as a stack is really helpful to understand how it processes information. It's not just a passive bucket for data. It's an active machine.
Let's walk through the stack from the bottom up. Layer 1, the data source layer.
This is the input zone. This is the eyes and ears of the system. This layer leverages API's application programming interfaces to hook directly into those external tools we just mentioned.
So it's got a tentacle in Doors, a tentacle in Jira, and a tentacle in Git.
Exactly. Its only job is accurate importing and synchronization. It's just grabbing the raw material of the project. And it's constantly polling. Has the code changed? Has a requirement been updated? Is there a new Jira ticket?
Okay, so it sucks up all that data. Then it passes it up the stack to layer 2, the processing layer.
This is the brain of the operation. This is really where the magic happens. It takes that raw data from all the different sources and it parses it, usually converting it into a standardized format like JSON.
Why JSON?
JSON is a standard data interchange format. It's lightweight, it's human readable, but most importantly, it's easy for machines to read. See, Git speaks in the language of code commits, diffs, branches. Doors speaks in structured text.
They're different languages.
Completely different. Layer 2 translates them all into a common language JSON, so they can actually be compared and linked.
But the paper says it does more than just translate. It also performs validation.
This is critical.
Yeah.
This is so important. It verifies the integrity of the data before it moves any further up the stack. It checks for gaps or discrepancies right away.
Give me an example.
Okay, let's say a developer commits some code to Git and puts a tag in the comment. Implements requirement R5. The processing layer sees that tag. It immediately checks the data it got from doors and asks, does requirement R5 actually exist? Is it a valid, approved requirement for this project? If the answer is no, it flags it immediately as an error.
So it prevents garbage in, garbage out?
Precisely. It catches those traceability gaps right there at the ingestion point. It stops the corruption of the central database before it can even happen.
Very smart. Then we move up to layer 3, the centralized storage layer.
This is the memory. This is the CertiA360 database itself. It's a unified repository. It stores all those project artifacts, the requirements, the code snippets, the test results, but most importantly, it stores the relationships, the links between them.
It's a graph, essentially, isn't it?
Yes. In computer science terms, it's a graph database.
Yeah.
You have nodes, which are the artifacts like requirements or code files, and you have edges, which represent the links between them.
And that structure is what allows for the complex queries later on.
Exactly. It's built for understanding relationships.
And finally, at the top, we have layer 4, the framework layer.
This is the interface. This is what the human being actually sees and uses. This layer powers the dashboards, the traceability graphs, the reports. It's where the engineer or the manager logs in to see the health of the project.
So the engineer doesn't have to write complex database queries in JSON. They just see a dashboard that says traceability coverage, 98% compliant.
Exactly. It turns all that raw data from the bottom layers into actionable intelligence at the top.
Which is the perfect segue to section 4, the killer features. Because the architecture is cool, but what does this actually do for that stressed out engineer who has a compliance audit next week?
It does a lot. The research really highlights 3 main features that directly solve this Agile versus compliance conflict.
Let's start with feature A, automated traceability visualization.
Right. We talked about how hard manual traceability is, how it's like finding a needle in a haystack.
Linking line 405 of code back to requirement 2.1.3 in some Word document.
CertiA360 turns that entire mess into a graphical visualization. Imagine a spider web or a constellation map. You can see a node representing a requirement. You see a line connecting it to a design node, a line connecting that to a code node, and a line from there to a test node.
So you can actually see the chain we were talking about earlier.
You can see it, and you can interact with it. You can filter. You can ask the system, show me all high-level requirements that don't have a test case linked to them yet, and boom, they light up red on your screen.
Oh.
Or show me all the code modules that are affected by this one specific high-level safety requirement.
That is a game changer for a DO 178C audit.
It completely satisfies the requirement for ensuring every line of code has a reason to exist. And more importantly, it makes it visually obvious when something doesn't have a link. It turns a compliance audit from a generic scavenger hunt into a targeted visual check.
I love that. Okay, feature B. This one I think is the real secret sauce for enabling Agile, change request management.
This is the Agile enabler, for sure.
Set the scene for us again. Why is change so dangerous in aerospace?
Okay, let's say you are in the middle of a 2-week sprint. You find a bug in the navigation code. In a pure, agile, non-aerospace world, you fix it. You push the code, you deploy it. It's fast.
But in aerospace...
If you just fix it, you might have just broken your certification. You might have invalidated the entire traceability chain. Does that fix still match the original requirement? Did you remember to update the design document? Did you run all the necessary regression tests?
And more importantly, does that one little fix inadvertently break the autopilot system?
Exactly. The ripple effect. In the old way, figuring out the impact of a single line of code change might take a change control board meeting with 10 people in a room and 3 weeks of analysis.
Which completely kills the sprint. There's no agility there.
None. So CertiA360 proposes a new workflow. The user creates a formal change request within the tool.
Okay, a digital form.
Right. And as soon as they submit it, the tool performs an automated impact analysis.
Impact analysis, that sounds cool. What is it doing?
It's like a blast radius calculator for code. Because the tool already knows all the connections. Remember that graph database. It can instantly tell you, if you change this one piece of code, Here are the 5 requirements, 3 design documents, and 12 tests that are directly or indirectly affected.
Wow. So it tells you exactly what you need to go back and check.
Instantly. It
Mhm.
generates a map of every single artifact affected by this proposed change.
And then what happens?
Then it notifies the relevant teams automatically. This is the bug resolution workflow part. It pings the requirements team and says, hey, requirement X is being touched by this change. It tells the test team, hey, you need to rerun these specific 12 tests.
So it creates this automatic cross-team transparency.
It allows development to stay agile. You can identify and fix bugs fast, but it keeps the project compliant because the traceability is updated and the full impact is understood and documented automatically.
It effectively removes the excuse of, oh, I didn't know that my code touched that other system.
Exactly. The machine knows, and the machine tells you.
Okay, that's huge. What about feature C, baseline creation and configuration indexing? That sounds like administrative building stuff, but tell me why it matters.
It is administrative, but it is absolutely essential for audits and certification. Think of it as taking a snapshot of the entire project at a moment in time.
A snapshot of everything. The code, the requirements.
Everything. A baseline. In software, things are always moving. The code you have on your machine today is different from what you had yesterday. But for certification, you need to be able to say with absolute certainty, this is version 1.0, this is the exact state of everything on this date.
Right. You can't certify a moving target.
Precisely. So CertiA360 can capture the state of all requirements, all code, the entire project backlog at a specific moment, and essentially lock it. This is crucial for something called DO330, which we'll get to, and for any audits. It proves exactly what the software looked like at the time it was certified.
So when the auditor shows up 6 months later, you can just pull up that baseline and say, here's the exact version of what we flew with.
Exactly. And configuration indexing is just a fancy way of saying we have a detailed list, a manifest, of every version of every single file that went into that build.
Yeah.
It's the ultimate rigorous record keeping, but automated.
So we've got this amazing tool. It connects everything. It visualizes the invisible. It automates the paperwork. Is it perfect? Is it ready to take over the world today?
Well, this brings us to Section 5, validation and limitations. And we have to be realistic here.
The paper is clear that this is a proof of concept, right?
Correct. It was designed in close collaboration with aerospace experts, so it's solving real, practical problems. It's not just an academic theory. But
There's always a but.
the tool itself is not yet qualified under DO330.
Okay, explain DO330. We mentioned it briefly with the supplements before. What is it?
DO330 is software tool qualification considerations. And here is the great catch-22 of aerospace software. If you use a tool to check your software, and you want to trust that tool implicitly, meaning you don't want to have a human double-check all of the tools work manually,
Right.
then the tool itself has to be certified.
Oh, wow. So the checker needs a checker.
Yes, if CertiA360 is going to be the thing that says, this software is safe, trust me, then CertiA360 itself has to be proven to be error-free to an incredibly high standard.
But wait, isn't that a recursive nightmare? If I use another tool to check CertiA360, does that tool also need to be certified?
Theoretically, yes, but practically, you usually get around that by verifying the tool through extensive testing, formal methods, and a long history of reliable use. But the point is, CertiA360 in this research is not yet at that qualification level.
So right now, it's not a legal replacement for human eyes.
No. Right now, it's a helper, a very powerful one. You can use it to build the software, you can use it to find the gaps, you can use it to generate the reports, but ultimately, a human-designated engineering representative probably still has to sign off on the final output because the tool isn't fully qualified to replace that verification step yet.
That makes perfect sense. It's a powerful assistant, but it's not yet the pilot.
That's a great way to put it, exactly. But the findings from the research are still very, very positive. They proved that this kind of automation does reduce manual effort significantly. And they proved the core thesis, that Agile can coexist with safety-critical systems if the tooling supports it.
You can't just do Agile with a whiteboard and some sticky notes in an aerospace context. You need this kind of digital infrastructure.
You need the infrastructure to handle the immense weight of the documentation and proof that's required.
So where does this go from here? What's the future for a tool like this?
The paper suggests a few exciting directions. First, expansion. Aerospace isn't the only rigid safety-critical industry out there.
Right. You've got railways, automotive, medical devices.
They all have very similar standards.
Yeah.
Automotive has ISO 26262. Medical have IEC 62304. This concept of a centralized automated traceability hub works for all of them.
And what about predictive analytics? That sounds interesting.
This is the really exciting part, I think. Future versions could use machine learning to predict where compliance gaps might happen before they even occur.
So it could be like, hey, you're writing code in a module that historically has a lot of bugs, and you haven't linked a test case yet. You should probably watch out.
Exactly that. Or, this new change request you just filed affects a very fragile, very critical part of the system. We recommend extra peer review and testing, using historical data to prevent future issues, not just track them after the fact.
And then there's the dream of continuous certification.
That is the ultimate goal, the holy grail. Currently, certification is this massive panic at the end of the project, a huge, stressful paperwork exercise.
The crunch time.
Yep.
To end all crunch times.
Right. Continuous certification means you are essentially certifying as you code. Every single time a developer commits new code, the tool automatically checks the traceability, runs the required tests, updates the documents. So at the end of the project, you don't have a mountain of paperwork to do. You just hit print.
That sounds like absolute utopia for these engineers.
It would be a revolution. It would allow these legacy, safety-critical industries to finally move at the speed of software.
But it does bring up a provocative thought to leave us with. We talked about the tool itself becoming qualified under DO-330.
Yes.
As tools like CertiA360 become more capable, more intelligent, are we reaching a point where the software certifies the software?
That is the big philosophical question, isn't it?
If the tool is smart enough to map every change, validate every requirement, and predict every potential failure, does the role of the human certification officer change fundamentally?
I think it has to. The human moves from being a checker, a manual verifier, to being the architect of the checking system.
So instead of checking the work, your job is to check the machine that checks the work to make sure the rules are right.
Yes. We're already seeing a massive shift in society towards trusting algorithms to verify our safety in other areas. And the question for aerospace is, are we ready to trust an algorithm to tell us if our planes are safe?
Continuous certification. It sounds so efficient, but it requires a massive leap of faith in the tool itself.
It does. But looking at the complexity of modern systems, we're talking millions, sometimes tens of millions of lines of code, we might not have a choice. The systems are becoming too complex for any single human or even a team of humans to check manually. We need the tools.
We might need the machines to save us from the complexity of the machines we've already built.
That is a very poetic irony.
Indeed. Thank you for diving into this with us. It's a niche topic, aerospace compliance, but the implications for how we build everything important in the future are just huge.
Absolutely. It's a fascinating space.
And to our listeners, think about your own industry. Are you stuck in a rigid process? Could better tooling unlock your own agile transformation? Something to mull over. Thanks for listening to The Deep Dive. We'll see you next time.
Safe flying.